Welcome to Unit 5.5. Today we're going to be talking about using candidates tests to determine absolute extremas. Now, candidates for absolute extremas are either your critical points, so when f prime equals 0 or does not exist, and your endpoints. So to see the candidates test, let's do an example. If I have f of x equals 1 plus x plus 1 to the power of 2 on the interval negative 2 to 5, the first thing I want to do is find my critical point. So to find your critical point, you want to take your derivative and set equal to 0. So we have f prime of x equals, the 1 becomes a 0. Bring it to x plus 1. The 0 goes away, and I have f prime of x equals 2 x plus 1. I set it equal to 0, and then I solve for x. 0 cannot equal 2, and x plus 1 equals 0. So we have a critical point at x equals negative 1. Now that we have found our critical point, we have to set up a table. So this table would look like x on one side, and our original equation, so our f of x on the other side. So our original equation is f of x equals 1 plus x plus 1 to the power of 2. So for our x values, we use our interval. So our interval goes from negative 2 to 5. So we will use numbers in between negative 2 and 5. We also want to include our critical points, so we have negative 1, which is between negative 2 and 5. And here we just plug in our x values into our original equation. And since we're determining our absolute extremas, we want to see which number comes out to be the largest value and the smallest value. So first, let's plug in our equation. So f of negative 2 equals 1 plus negative 2 plus 1 power 2. f of negative 1 equals 1 plus negative 1 plus 1 to the power 2. And f of 5 equals 1 plus 5 plus 1 to the power of 2. And solve. After solving, I have negative 2, 2, negative 1, 1, and 5, 37. So, since we have 37 as our largest f of x value, then this would be our absolute maximum. And since 1 is our smallest f of x value, it would be our absolute minimum. Thank you.